Our presentation is on matrix encryption. So cryptography is a method of protecting information and communications through the use of codes, which are encrypting and decrypting messages, so that only those for whom the information is intended for can read and process it. And this relates to cryptology, which is the mathematics behind cryptography, and cryptanalysis, which is the study of ciphers. So depending on how advanced your cryptography is and how much you study cryptanalysis, your cryptography can be more secure. And those who apply cryptography in real-world applications are called cryptographers, and they study better ways to encode and decode text. And these people are mostly seen in larger businesses to ensure that the information being processed among servers is being processed in a secure way so information will not be stolen. So some simple methods of cryptography, probably the most famous one and the most studied one is the Caesar cipher. It's one of the most elementary methods of cryptography, and it involves simply shifting each letter by a given random number. So instead of having like the string ABC, you would shift it down 3 letters and it would turn into DEF. And other methods include algorithmic encryption and RSA, and these are more complicated methods and used by more companies and governments to encrypt their information in a way that is nearly impossible to crack. And so algorithmic encryption is utilized by PGP, which stands for Pretty Good Privacy, which is just a simple cipher that you can download on your computer, and it encrypts information in a way that takes days or months to crack. And then GNU Privacy Guard, which does the same thing but it's a little bit more secure. And the security depends on the accuracy of computing discrete logs. So algorithmic encryption uses a simple formula that has logarithmic functions in it, and so depending on how well your computer or your cracking device can solve discrete logs with a certain point of accuracy shows how much you can decrypt the message. And RSA is a standard encryption similar to matrix encryption, and the security of the text depends on factoring large integers. So RSA uses some random numbers, and those random numbers can be up to 200 to 300 digits. So based on how well your computing device can factor large integers is how fast you can decrypt RSA messages. So the cryptography method we're studying is matrix cryptography. It is used by governments and was the most secure form of cryptography. So it uses the matrix to encode and the inverse of the matrix to decode it. So in this picture here, your simple message is given by the 4x1 matrix, and then your encoding matrix is a 4x4. So the matrix with message is made by giving the letters and spaces a number value and making that into vectors. So for example, 0 will correspond to the space, 1 will correspond to A, all the way going up to Z. And you take the vectors and make them into one big matrix to contain the message. And to encode the matrix, you multiply the message matrix by the encoding matrix, and that is shown above. And to decode this matrix, you multiply by the inverse of the coding matrix and use the values of the letter to decrypt the message. So you simply just multiply those two matrices again, except with the inverse of the encoding matrix.
Me and Ashley did our final project or application project in cryptography and how it relates to linear algebra. Cryptography relates to linear algebra because it uses matrices to encrypt and decrypt a message. To encrypt a message, you take a matrix of your own choosing that can be multiplied by the message that you have turned into a matrix. In most cases, or in the example case that I will show in a few seconds, it is a 3x3 matrix that we encrypt with and decrypt with. And to decrypt the message, you would just have to multiply by the inverse of the encryption matrix to get back to the original message. So in this example, our starting message is simple messages. And this 243634232 is our encryption matrix. And then this matrix is simple messages in a matrix. How we did this was we made each letter correspond to its value if you went A is 1 and Z is 26. So S is 19, I is 9, M is 13, and so on. And a space in this case is 0. So you multiply these two matrices together, and then you get this matrix, which is what's going to be sent. That's how the message will be sent to the recipient. And then what they would have to do, or their computer would have to do, is take the inverse of the encryption matrix, which is this matrix down here now, and multiply it by the matrix that we gave it. And then they would get the message, or they would get this matrix back. And then they would further take that and take the numbers, and they would take the numbers and correspond it to the letter, and then they would be able to discern what message we were trying to send them.